Yeah, thank you. Yeah, Yogesh and
Thank you so
Manoj.
much, Manoj. Yeah, thank you.
Okay, welcome.
If they ask anything regarding MapReduce, do we need to need to write pseudocode? Is pseudocode enough?
Yeah. I think by default, now if it is not given explicitly, right, you can write a pseudocode. And I think it's weird if they ask you to write in Java because
No, I
everyone
think
is not. Yeah.
lot of questions we could see like pseudocode for basic
Yes.
aggregation functions. So we need
Yeah.
to be like at least like get in touch with that.
Yeah.
Most of the question has that.
But if they
Uh,
have explicitly mentioned, then you have to use that.
so this Spark, Hive, and Pig, all this deals only with the structured form of data.
No, not necessarily.
No,
Spark can deal unstructured also.
that's why
But
it is part of
now,
big data, right?
Yeah.
yeah,
But
actually, big data means.
yes, yeah.
But now in our syllabus, now they are dealing only with the structured data to get
No, I
understanding what
mean,
it is.
probably it's understanding, but it can read any data actually.
Mhm.
Yeah.
Okay, thank
Probably
you.
we can discuss in this videos. I think let's
Yeah, in
start
future.
Spark. Yeah.
Yeah, thank you.
Mhm.
Thank you so much.
Started, right?
Oh, you are continuing SPA in this call itself, huh?
Yeah.
Ah, yes.
Okay, I think then recording should have stopped it, I think, right?
Yeah, recording is stopped and I restarted it.
Oh, thank you so much. Okay, I'm leaving now. Right, thank you.
Ah, you are not in videos now. Okay.
No, I'm not in SPA.
Oh, okay.
VDS.
SPA, right. Yeah. Okay.
Okay, thank
Yeah, let's start.
Consider the following Kafka cluster description. Consider the following Kafka cluster description. Dot cluster, name of topic bus, name number of partition 3, replication factor of bus 2, 3 producers, 2 consumers. Draw Kafka architecture clearly, highlighting the following in block diagram: producer, consumer, broker, topic, partitions.
We don't
So I
have.
think we just have to draw some boxes. Like in the center, we can call it as a Kafka broker, right? It is having 4 nodes, right? We can just mention node 1, node 2, node 3, node 4. 4 node like Kafka broker. And if you see the producer, right, they have given 3 producers. So on the left hand side, when we say it's a producer, no, so we can draw 3 boxes. Producer 1, producer 2, and producer 3. Similarly, on the right, we have 2 consumers, consumer 1 and consumer 2. Topic name is bus is given. We have to highlight in the line connection from the producer to this one, right? When we connect producer to the broker and the broker to consumer, we can highlight somewhere topic name like bus.
Yogesh, you have something to share or show something?
I'm just trying actually, Manuja. I
Okay.
think Veena is trying already, but I also try. If I find something, I will share also.
Yeah. Okay, let me also find something. Please.
I've tried to draw it on my copy with my pen.
Oh, okay.
Um, I can try
Want
to
to share?
show. Yeah, it's not very much let's try. Okay, if you can guys able to see, I'll turn on my video and see if I can change it. Like I just is it visible?
Oh, I think it's if you can you send it to WhatsApp or something picture. We can
Uh,
drag it from there to this chat.
okay, I'll do that.
That will
Just a
be easy,
second.
no? Yeah, that will be easy. Otherwise, it will be very hard for you to just focus which area you are explaining.
Yeah, okay. I'll
Just trying to get something from the internet to show. So, okay.
Manoj,
Yeah.
am I okay? I'm sharing it to you personally. You can share it in this chat. Is it fine?
You can share it in the group itself, SEM3 combined study group, or in the SPA group. You can share it. No?
Yeah, and
Okay,
Veena,
okay,
you
let's see.
can
Yeah,
you
we
can
can take it
open it
there,
from
like,
there, no? Yes, yes.
Yeah, I can.
You are
think I
shy
got
to share
something
it there, or what?
Okay, meanwhile, can I share
Yeah, yeah.
just to
Correct.
show, just see, meanwhile, just to see if that helps.
Yeah, I've shared it. I've shared it on that group. Okay, so if you can open it, actually, I think most of the thing I've done, I just have confusion around one thing. Although my diagram is not very much clear, but see if you can make any sense out of it.
Okay, let me open it also. Currently, I'm sharing my screen. I will open that so you can explain, Anand.
P1, P2, P3.
Yeah. Sorry, when I just shared my screen without asking you. Yeah. Oops. Okay. 1 second. So let me know if this is Anand shared
Okay,
this image.
yeah, I'll try to explain this. I know it's not very much clear. So basically, see, we have three partitions and two replication factor. That's the reason. Basically, these the two boxes, they are representing topic, right? And the three boxes inside the topic is showing the topic partition. I probably should have named it. So, and since we have two replication factor, that's the reason I have kept two topic partitions. And we have two consumers and three producers. All the producers, they will be producing the data onto these topics with the different applications, and consumers will be all the consumers C1 and C2, they will be consuming data from this topic. Like, this is my basic idea. Like, this is the basic idea which I wanted to draw.
No,
Yeah, let's
just
see
I
the
want to
similar.
clarify.
Can
Can you
I
tell me the
can I
replication?
share one pic 1 minute? I'm sharing it in group.
You see, if you hear this also, right? You see the broker, the Kafka cluster, right? And they have mentioned in the question 4 node cluster. So here we have to have, this is broker 1, broker 2, broker 3, and one more broker. So currently they have shown 3. We have to show one more here to show the 4 brokers in this Kafka cluster. And now partition also, they ask, right? 3 partitions, right?
They gave only one
Yeah.
broker, right? One broker and 4 nodes.
No, I think the 4 node, right? Kafka cluster, they have in the question, it's 4 node cluster, right?
4 node
Cluster.
cluster
Yeah.
and one
It's
broker.
4 node cluster.
Brokers?
No, broker they haven't mentioned.
Okay.
Yeah, I think each node is like a broker now. So here we have 4 nodes: broker 1, broker 2, broker 3, and one more broker 4, right? And now we have a topic right here. See, now we have given a topic called bus, right? So we can call it as bus, and we can call partition 0, partition 1, and partition 2. So these 3 will be there for each. There are 4 nodes. Each will have 3 partitions. Okay, and as is given, three producers, and it will only need 2 consumers here, not 3.
Yeah, but how will you? Yeah, but how will you
One
calculate
thing
the
missing is the
replication
replication factor.
factor?
Replication is
How
not.
will you?
Yeah, replication is nothing but copy. How many copies you want to keep it in a broker, right?
Exactly. You can show here also, right? I mean, now here the one copy here, the same copy you can show some other node. See, there are 4 nodes, right? So 1, 2, 3, and 4. One copy is here. Same copy you can show some other node also. How
Yes.
much is the replication factor? You shared something?
2.
2. So now here we can say this part, right? Suppose this is a one copy, partition. So same color or same thing we can show exactly same here also. to depict, okay, to show the same data element is replicated one more time, like a 2 copies, like a replication factor 2. So if this node fails, we always can get it from this node. So likewise.
Yeah,
Does that
I
make
shared
sense?
one. Yeah, makes
Okay.
sense. I shared similar image. Can you please open that in WhatsApp group?
WhatsApp group, 1 second.
Yeah, is it? I think.
1
Can I
second.
rotate and?
Let me save it and then open it, okay? Or if you have it and you can also take the screen, anything is fine.
Yeah. Or else I will send another image if you find any
No,
difficulty.
yeah, it's
Okay.
already there. Download. Say one. Let me open it from my system here, okay? And then I can rotate it. Yeah, it's opening. But I mean, we got a high level idea,
Correct.
right? How we have to just show like this. Yeah, it's opening. Give me 1 minute. Okay, I will do. I'm just rotating it. Okay, fine. It is clearly visible now.
Yeah, it is visible.
Yeah,
and we'll have
see.
Zookeeper at the bottom. Zookeeper, I missed it. Zookeeper. Okay. Yeah, bottom. There will be a Zookeeper node. Like Zookeeper will be responsible for complete cluster, right? So we can draw a rectangle below to that box. One rectangle. So this is a 4-node cluster. 1, 2, 3, 4 nodes. So there will be one leader, and so copies will be maintained into replication factor is 2, right? So P1 will be available in one node and P2 copy will be in second one, and P2 copy also same thing. So
P2
we can
having 2 copies, one on this node and one on this node.
Yes. P3 also same thing.
Yes. And these are nothing but partitions and topic, same topic, correct?
Yes, same topic.
Yeah.
Bus topic they're given, right?
Here P1 is what? The police topic. P1 is what?
Partition 1.
Partition. Yeah.
Partition
So
1,
we have,
partition 2, partition 3.
yeah, one topic we have bus, but there are 3 partitions, and he mentioned here partition P1, P2, and P3. Since the replication factor is 2, each partition will have 2 copies, one on one node and one on some other node. So here, if it is P1 on this node, P2 has to be some other node here actually, right? So in case if one node goes down, we will not lose the complete data. Yeah, this is kind of a diagram we have to write it, I mean, make it.
Yeah, below we need to draw that Zookeeper as well. So Zookeeper will be there. Below to this rectangle, there will be another rectangle. Zookeeper we need to mention, that's it.
Okay, so here one question. So whenever any broker or any node, if it has the original partition, right? Original partition, like if it is P1 or P2 or P3, any of the broker, original partition, so that will be leader.
Yeah, right? Leader is what actually you are trying to indicate? Broker. Leader is broker or something?
No. So there is another diagram also, right? In GoTAT's class they shown. So leader is nothing but, so it's just a copy. It's not a leader, and so we have 2 copies of one partition. That's it. Don't confuse
one
with this.
One partition below you written leader, and the copy you made
copy.
No.
Just I think for the confusion to add, just ignore this leader now.
Yeah, leader. Ignore that. Ignore that.
Just say you have a partition P1 copy 2 times, one in this node and one on this node.
Correct.
Yeah, that will be easy. Yeah, but still, out of 4 brokers, there will be one leader, but that is, I think, randomly decided, or some, I don't know, some. But leader is the one which maintains the synchronization or assigns the tasks to the other nodes in the cluster. So actually, there is a concept of leader, but maybe we can skip it for the time being.
Yeah. Leader will be elected based on the leadership election, which will be done at the time of polling. So I think that is different concept. So here that will not come. You can ignore that leader part.
Yeah. But yeah, for this simplicity, I think this is good enough, I believe too.
Yep.
Just we have to add a zookeeper.
See, 4 node you drawn on top of that topic P1, P2, P3. Whether it is required because already in the, among the 4 node topic we have mentioned. Now one is copy, another is original. On top of that, whether we need to write this topic P1, P2, P3 or not required.
So topic is a logical group of
That
the
is okay.
messages.
That I understood. I'm telling that top of the square box, rectangle box you written, not topic P1, P2, P3. Whether it is required.
If you mention that is okay. If you remove that and mention it near to that box also, it is fine. Topic 1, topic.
Sudeep, I think it is
Actually, it is
required.
topic
Why?
partitions. See,
Yeah.
it is topic partitions, right? And there should be one more heading above. There should be bus. So under bus, you have 3 partitions: P1, P2, P3.
Which is wireless. What you can say here, you can say topic in double quote B bus, okay, and then partition you can mention. Okay, these are the 3 partitions: P1, P2, P3. And Sudeep, your question is on this one, or where is your exact question?
Top side, whether that is required or without, because topic already we have mentioned among the node, right? Topic and its copy we have distributed. So I thought
just like for the clarity, he mentioned here 1 topic, 3 partitions.
Yes,
I mean, it's good to mention. I don't think even though you don't mention, otherwise then you have to show something. Okay, these are the partitions, right? Somewhere you have to write here partition P1, P2, P3 are nothing but partitions. So that's what he mentioned here.
Okay, I will write.
And again, here P1 and here P1, not just have a distinction. No? Like you can write
producer.
You can say producer 1, producer 2, producer 3. Other it will become like a P1, P1. Yeah. Maybe you can draw a diagram and give some, heading like this. These are the producers. These are the consumers. Likewise.
Yes, correct.
That will be more clear. Any questions from anyone, or good? Everyone good with this?
Is 4 node down the line, whether we should write Booker 1, Booker 2, Booker 3, Booker 4, or just like
you can write anything. Yeah, you can write anything. You just have to show that, okay, this is 1 node, right? Maybe you can have like an arrow here saying this one, this and this, right? Say you can brokers, right? This is this is the nothing but big box is nothing but Kafka cluster, like other diagram. No, let me show here. See here. So you can do like this also. So on the big box, you can say this is a Kafka cluster, and each node you can say a name broker 1 or whatever name you can give. Or if you don't give, you have to just mention somewhere. No, you just indicate by arrow saying these are the brokers, right? 4 brokers.
Okay, it is good to go ahead.
Clear? Yeah. Okay, Veena, you can take your screen. Let me stop sharing.
Something similar. So
we could have referred this also. It's there only. Okay.
I will keep the score image in that.
See the color combination now, it's given nicely here.
Yeah.
Yes.
Something we can follow.
Yeah.
But it contains 5 brokers.
Correct.
And
so I will just put for reference.
Yeah. Offset also we no need to mention. So if you mention offset, then I think.
Okay. What is the segment file, index file?
These are internal, means how it fetches the file and all. It will be based on these.
But did it mention anywhere? It's mentioned here in question.
No, it's not needed. Only this part is needed in the answer. Producer, partition, broker, and consumer. And in broker, we need to mention partition and replication.
Yeah. See, broker 1 to 5 given. Oh, why did they give 5? Is it 4? It's 4 only, right? In the question.
It's not related to this question.
Oh, not really. Okay. Fine. Then fine. I was just trying to compare. I thought this answer is related to that question. Yeah, this is very clear now. With the color combination, it's easily we can make it.
Yeah, and if we can know this, what is segment file, the right to that is a related concept, then that would be complete in itself. Yeah, maybe some other day we can. But this we don't. Maybe somewhere this question may come. No, segment file, index file, offset. I don't know. Yeah, just guessing.
We haven't covered it in our topics yet.
Generally, Kafka will backend, it will use the file system. So it will store the data in terms of file system. So this offset is the number of messages. How many messages are available in that topic? So it will be like if you know that ADS, right? In first semester, like it will store in 1, 2, 3, 4, 5 like that. Whatever how many messages we publish, it will store in that order, and it will consume from the 0. So that's how they mention like that. But in class also, I don't think they given any description about the segment file and index file. This is for just for how like it will store and retrieve the data. That's it.
Actually, yeah, you're right to some extent, because that's how this Kafka, it will write the data or read the data. There is an order. So how does it maintain the order? By using these offsets, by making use of the offsets. Now this segment file and the indexes, they are nothing but the offsets, some offset information. So based on that, it's like it keeps the record. It keeps the record of the messages that it has read or written. So let's say that your Kafka system restarts. Okay, so it knows that last time at which point it stopped, and it will start from there. How does it know? Because of it is keeping track of the data or messages in the form of offset and segments.
Correct.
I just shared the YouTube playlist. If you get a chance, this author, he has explained this concept very well, actually. Maybe first few videos, I think I shared earlier also, but first 2-3 videos also will give you a complete architecture on the Kafka. What is broker, topic, partitions, offset. Probably first 3 lectures, 3 sessions of this video should be giving you the clear idea. Yeah.
Next is how many consumer groups can be created for this configuration?
What is the question? Main question? If we can.
For the same architecture, how many consumer groups can be created?
Oh, can you scroll up? Is it like 3 consumers right there?
Correct.
2 consumers.
2 consumers.
2 consumers.
Generally, it will be only 1 because 2 consumers are reading from the same topic. So there will be only 1 group will be created by default. That's what I know, but need to see. I'm checking.
Correct. I don't think so. If there are 2 topics, then 2 consumer groups, 1 for each topic, right?
Yes, correct.
I think when we mentioned.
But at the time we have 2 consumers in the system. So what if like each consumer becomes, and it can become 1 group. So C1 can become 1 consumer group, C2 can become 1 consumer group, and in fact the combination of both can also become a group. So it looks like 3 to me, but even I'm also not sure.
Yeah.
I think
But
what concept of consumer group is like, right? Say we want to pull the data from the broker, correct? To the consumers to pull the data and to increase the parallelism, right? So we add multiple consumers, right? We create a consumer group. We have multiple consumers in that group so that the data which we want to pull it from the broker or the messages, we can do it in parallel.
correct.
Yes.
I mean, having one group per consumer, I don't know if it makes sense. Have to verify.
Yeah,
But
since
but
two
probably,
consumers are reading from the same topic, so there will be only one consumer group will be created.
huh, yeah,
And so they will be subscribed to the topic.
yeah,
So yeah, ideally it should be one.
yeah. I mean, the idea was if we have, say, many producers producing the messages, right? And suppose we have only one consumer and it is not able to catch up to that speed, then we need to add more this thing, right? Consumers. So
Correct.
we
More
form a
consumers
group.
we can add.
We can
Yes.
add, yes, and they
Then
can
it will
do
join
in
that group.
parallel. Exactly, and
Yes.
they can part of a single group, and they all can do it in parallel. Likewise.
Yes, yes. Basically how, so I think they only started the Kafka, how it will work, right? But the next step will be whenever a consumer is joined, right? These partitions will be assigned to the consumer. That is how.
Ha,
So that
ha,
is the
ha.
next sem, like next sem part, I think. So based on that, this partition will be assigned to the consumers and produce like they will be processed automatically. But for now, this question, I think only one, I think.
So just to clarify, I'm just for my understanding also, say if we have a broker with three partitions, correct? So we
Correct.
can have three consumers, one consumer reading from one partition, and these three
Correct.
can read from three partition in parallel, correct? And if there
Each
are, say, yeah,
each consumer will assign to one partition. So
one
it's not
partition.
parallel three. So if we have only two partitions, three consumers, then only two
Yes,
will be assigned to two, one will be idle.
exactly, exactly.
So
I'm coming to that also. Yes, yes. And
yeah,
if there are more partitions, say four partitions, but only three consumers, then one consumer will read from two partitions,
two
while
partitions.
others,
Two will
yeah,
be
yeah,
assigned to one consumer. It will be that assignment will be done by Kafka.
yeah.
No, why one consumer cannot be assigned all the partitions? What is the problem?
All the
So
single consumer. See, I mean, if you try to one consumer actually, right? So that we have, say, multiple nodes, right? And if you have only one consumer and if you try to read all the messages, right, it will take time. Probably it is not. I mean, you will have more data coming in, but you are not able to process it, in the similar speed. And that's why we create multiple partitions to achieve the parallelism. In the Kafka cluster, we create multiple partition, and also we create multiple consumers, so we can have, multiple consumers consuming from respective partitions, so that the processing or consumption of the messages from the cluster, it can be faster.
Partition is done by producer, or who is creating partition?
So we can configure. Yes,
yeah,
Shaikh, go on.
yeah. So while producing, we can configure the partitions. While creating the topic, we'll give the number of partitions so that topic will be created based on the partitions which we given. So while doing the produce, right, there will be a partition key. In the message itself, we will specify the partition key. Based on that partition key, which we specify in the producer, based on that messages will be distributed. There will be a logic. So if you specify integer as a partition key, it will do the modulo division and assign. So it will be, I think, for first made, right, I don't think it is required. So, but second mid we require that. For now, I think until the cluster, how many brokers, how it will get assigned, it is up to that extent, it is okay, I think.
Yeah, probably the architecture side, no?
Architecture,
How?
yeah, how
Yeah.
it will get created and how it will assign partitions.
Correct.
How in the broker. So until that, stuff it is enough, I think, for now.
Yeah, I also think so.
Yeah. But there will be some other theory how partitions will be assigned and how partition will be assigned to consumers. Producer said how can we produce the messages? They will be assigned to the specific partitions. That is the second part.
Mhm. Yeah, I think we can have a detailed discussion post midterm, and
Yeah.
also it's a
So
good idea if we
basically
can go
consumer
through these
group,
videos.
yeah, basically consumer group will be specified at the time, like consumer will have some code where it will specify name of the consumer group. So to the same consumer group, it will so all consumers will join that group. So the topic partitions will be readed, like topics messages will be readed from that consumers. So that's how it will be for now.
I think this is
Enough.
good for this question, right?
Yes.
Yeah.
Next one, I think A, B,
Oh,
C, something.
this has some scenarios, similar scenarios, so we can go through it. Means if still questions are there, right? So you can just go through this. So it has detailed explanation, multiple scenarios are there.
This
Yeah,
link
maybe
you have
Veena,
shared.
could you share the link to the chat,
Link
please?
can you
Yeah, I
share?
have added it in the chat group.
Okay.
Speak group, I have added this.
but I think we can expect such kind of a question to draw the
What is the link name you have
diagram.
given? Apache Kafka playlist I am seeing. That is only.
No, she's sharing the list.
Not
Veena,
yet
I think,
shared.
yeah, she will be sharing the link that she was just showing.
Oh, in the WhatsApp it is there.
Oh, she has shared in WhatsApp. Okay. You can share here also, Veena. I think Sudeep is mentioning here.
Yeah, but I feel that here the answer should be two. Like each consumer can act itself as a group. So there can be two consumer group, wherein each consumer group will only have one consumer. So this can be the case, right? For the B question, for the B part.
I'm not 100% sure because it's one topic. So let me check.
Because topic partitions, I think it is possible
So
that each
the
consumer
same
actually.
partition will not be shared with the other consumer. So if we make two different groups, right, we might have to give the same partition to both. So that will create data duplicacy.
Correct. So ideally it will not assign the same partition to the different consumer.
Sorry,
Uh,
it will not assign the same partition within the consumer, multiple consumers. I mean, within the consumer group, if there are multiple consumers, it will not assign the same partition, so that that same message is not read by the two different. I mean, say we have two consumers in a consumer group. Same message is not read by the both the consumers. That will not create data duplicacy. But I can have multiple consumer groups,
Yes.
which
yes,
can read the which can
yes,
read,
which can.
yeah, read. So that way the data duplicacy doesn't, it can be different consumer groups in sense like say different Paytm application can also read to the same group, and phone pay can also read listen to the same topic, and
Yeah, exactly.
it can be two different consumer groups, so they want the
Yeah,
same
that's
data,
clear.
so duplicacy can happen there.
But again, we have to here remember, right? Even though it's duplicacy, but there are two different, downstream applications, right? Here
Correct,
we can
correct,
also
Yeah.
assume consumer one
Yes.
is nothing but one application, which is completely independent of the consumer two.
But
right.
I have a question.
Yes.
So there is a Kafka message commit, right? For
Mm-hmm.
example, if we commit the message
Mm-hmm.
from one consumer group, how second one will be read it? So
But consumer one means why consumer one consumer will commit the message. When consumers, okay, and on the sync, on the final, the sync where the consumers are writing the data, right? Because that way, that is where it will commit, right?
Yeah, commit
Before that, if it
once.
is,
Yeah, once we commit the message, then only that next message will be read right from our next consumer. Like, so that is how it will be. Next message it will pick. Yeah, that will be. I think it is too much confusing now. So if
yeah.
you,
See, because this, if let's say there are two consumers and one consumer is, let's say, your Postgre connector, and then there is one more connector. It can be your S3 connector or maybe some other connector. So one is writing the data to some other sync, and one is writing the data to some other thing, and they are basically consuming the data from the different partitions, right? So in this way, it is possible, right?
yeah, okay, right. What is the next one? What is the maximum number? They must set that each. I think for
I think the C
C
part,
is three
yeah.
three consumers, right? Because we have three partitions.
Number
But
of partitions equals number of consumers.
Yeah, number of consumers.
but
That way we can
okay.
achieve the parallelism. Yeah.
Yeah, but see here, like we have this constraint that number of consumers are only two. So with the two consumer, what is the maximum number of consumers that each consumer can have while ensuring maximum parallelism? So
Okay.
maximum number of consumers that each consumer can have. Uh, so now this is a good question. What is the maximum number of consumers that
What
each
is the
consumer?
maximum number of consumers that each consumer group can have while ensuring maximum parallelism?
Yeah, because there are three partitions, no?
Three
So
partitions, three consumers, I
three
can say,
consumers
but
we can track. They've
but
given
they have
two,
only
but
two. Yeah, we can say
exactly.
with three consumers we can have maximum parallelism.
Exactly. If we add one more, then we can achieve one more. Yes, and we can have maximum parallelism. Because now only two consumers, right? One consumer will have two partitions to process.
Yes.
And then it might wait for the first partition to complete and then read the second, right?
Yes,
So,
yes.
but comparatively, if we add one more consumer, then very well, three consumers, three partition. That will be the maximum parallelism.
Yeah, but I doubt that like we can here, extend this number of consumers because they have mentioned this in the question that you have these pins, you have three producers, you have two consumers, you have four. So they have given the system details. Now from this details, what is the possible? I think this is what they are asking.
Can we read the question again just to clarify? Because that if that is given, then we already have two consumers.
What is the maximum number of? What is the maximum number of consumers that each consumer group can have while ensuring maximum parallelism?
So like here again, whatever we were thinking, either we create two consumer groups where each consumer group will have one consumer, or we have one consumer only both the consumers. So both ways will guarantee, like both ways will give you some parallelism. But which one is better? We create whether we go with the one with the two with the two consumer, or we create two consumer with two consumer group with one consumer each.
No, probably they have given two consumers, but they wanted to know to achieve the maximum parallelism. What you can see the question, right? What is the max that each consumer group can have, right? So probably they might expect us to suggest, okay, if we add one more consumer, we can achieve the maximum parallelism.
I'm also thinking the same.
Exactly, because now if you see, I mean, two, that is not the maximum. See, that is two, that is not the maximum parallelism, right? There is a parallelism, but that is not a maximum. But in order to achieve the maximum parallelism, we need a third consumer because there are three partitions. So if we have three consumers in a consumer group, then with the three partitions we have, then we can achieve the maximum parallelism.
Right. Actually, yes, we can answer this question diplomatically that if we are allowed to scale it, right? So with the three consumers, we'll definitely have the highest partitions, right? But let's say if we have to consider this okay, that you can create two consumer group and keep one consumer in each group, right? And second, you keep only one consumer and keep two consumers in that consumer group. So which is better?
Yeah, again, I will go with the second one because now there are two consumers consuming three partitions compared to one consumer consuming three partitions, right? So the maximum parallelism is happening in the second case, right? Because two consumers, they are consuming partitions. There is some parallelism. But in the first case where you have only one consumer, there is no parallelism at all because if there are three partitions, single consumer, it has to read one partition one by one, right? There is no parallelism there. But in the second case, in the second case you mentioned, right? If a consumer group has two consumers, there is a parallelism, but that is not maximum because there is third partition which is still wait. So as soon as one consumer finishes its partition, then it will be picked up that one. So that is not a maximum. To achieve the maximum parallelism, we have to add a third consumer. Then it can be, we can write like that, I guess.
Yeah, but one thing here, let's say that you have two consumers, two consumers and in two different groups. Now each consumer will be assigned one topic partition, right? So in the first case, okay, if each consumer is only assigned one topic partition, so in that case two partitions will be used and one will be unused. And while in the second case, if you have in a single consumer group two consumers are there, and if one partition is assigned to a single consumer and remaining two can be assigned to the another. Actually, I'm not sure, like because as per my knowledge, all the three partitions they should be assigned to the two consumers, right? So if one is assigned to one, the other one should consume the data from the other all the others partitions.
No, this partition assignment will be done. How it will be done is, for example, assume we have only one consumer. Okay. When consumer is send a request to join that group, right? It will send a join message like I want to join. So then it will share like how it will be there is. So we have three partitions. Those three partitions will be assigned to this consumer one. So when consumer 2 came and it sent a join request, right? Then these partitions will be rebalanced. So how it will be rebalanced is three partitions assigned to C1, right? So out of three, one, it will dynamically decide. It will assign either two or one to the second consumer. If third consumer send a join request, right? Subscribe and join request, then it will rebalance the partitions again. It will rebalance each and every consumer one. If fourth is joining, there is no partitions are pending, like no partitions are available. So it will not assign any partition. It will be idle. So that is how partition assignment will be done for the consumers. So in this case, right, since they are asking how can we maximize the parallelism, right? So since they given two consumers, so it's not maximum degree of parallelism. So if we have added the third consumer, then each will have one consumer, one partition assigned. So all like three messages will process in parallel.
Yeah.
That's how we can achieve the maximum parallelism. So that's how we can explain.
Yeah.
Okay. Okay.
But this partition rebalance will be, I think, it's not for this syllabus, like for this mid-sem syllabus. It is just up to architecture, I think.
Yeah, no, but rebalancing this happens, and somewhere in the Goteti mentioned this rebalancing and leader concept. He of course he did not go into it detail, little bit.
Yeah, correct.
And yeah. Anyways, we can I think go ahead. We can go ahead, but yes, we can definitely answer that with the three consumers. Definitely, that will be the best. That will be the optimal setting. Now, right?
Yes.
Now with the 2 consumers, maybe we are not able to achieve. I don't know. I mean,
Yes.
the 3 with the case with the 3 is the best.
Yeah, we
Yes.
can mention that way. I hope
Same mention here,
next
maximum
one.
number of consumer is equal to number of partitions in the topic. If there are more consumers than partition, then some of the consumers will be idle.
Yeah,
Correct.
Yeah, but what is the opposite case? If there are less consumers and the partitions are more, then
So
partitions will
for
be
one consumer, there will be more partitions will be assigned.
yes,
yes,
yeah,
yeah. So it will not be fully parallel then, right? Because
Yeah.
one consumer is having 2 partitions and second is having only 1 partition. So it will be less efficient than 3 consumers.
Yeah. At a time, it will get only one message. So
Yeah.
it will be not a fully parallel system. What is the next one?
I think D is done.
What is
Just now,
Yeah.
what is the maximum number of server failures? Oh, that setup can handle. Okay, 1 server failure.
One server, because
Yeah.
one server, if it fails, see, we
Yeah,
have
it
2
can handle.
more.
Yes. Yeah. And
No,
the
but
second
why?
it will
Like
become-
you have 4 nodes, right? So if you have 4 nodes, or you are the 4 replicas too, right? So why only one? I mean, if there are 2 nodes go down, okay, at a time,
It
so
will
the
not
other
be
2 will
able
also have the
to
copy.
identify the leader, right? The voting will fail with 2 nodes.
Not the leader, I guess. I'm just thinking 1 copy will go down, right?
Yes.
Yeah, yes, because you have replication factor too, right? So everybody
Yes.
will have some replica. So
Correct. I think if out of 4, suppose 1 is down, but other 3 still have 1 copy, right? From those partitions which are down now. But suppose one of the 3 remaining servers, if 1 goes down, then definitely some topics will be gone completely, because now both the replicas are gone, correct? You're getting right? So one server down, still we are fine, because the replica, the second copy, is present on one of the remaining 3 servers. So that is okay. 1 server failure is okay. But out of the remaining 3, if anyone fails, right? Anyone, then we will lose that whatever the copies, right? That will be completely gone then. Because already we lost 1 server, and those copies whose second copy is present on the second failure server, that will also go. So I think one server failure is the right one.
Yeah.
Considering that, we will not lose data. If the second server fails, we will 100% we will lose some partitions.
So anyway, there will be a timeout as well. So even that server fail and it came again, right? So since that topic will contain the message timeout, like after what time that message need to be auto archived, message retention.ms. So that message will be available in the topic. When server came again, it will be read that from the partition. So it will not be a problem. But coming to this number of server failure, there will be only one broker can fail at a time. If 2 brokers are failed, ideally it's need to wait until those brokers are came up again. Then only those messages will be consumed. But server we have only one cluster, right? One server, right? One nodes we have 4.
Four actually. In the cluster we have 4 servers. In the Kafka cluster we have 4
nodes.
servers.
Yes, 4 nodes.
Yes,
yeah,
4
yeah.
nodes. So one node failure we can still
One
handle.
node, yes.
Yeah, but the second node failure, we will lose the data, and probably we have to wait until one of the 2 failed ones come back, right?
Yes.
Yeah, ideally it should rebalance. Means whenever one node fails, right? The second node we should be able to rebalance the data.
I think it will not, because the data is already kept, right? The copies, right? I mean, if the example, if the first server goes down, right? And if you try to rebalance entire data again, it will be too time consuming. I feel so. It will just check whatever data is already stored to see that is now it's enough, because we haven't lost all the data elements. We have still the second copy. Any other thoughts?
But what if only, let's say, 3 servers go down, right? And one server is having 3 partitions, right? So that setting can also work, right?
No, but see, when you're 3 servers down, right?
Hmm.
So it is not like then. See, it means that that fourth remaining server, right? It should have all the copies indirectly.
But yeah, like yeah, it can have, yeah. Let's say that it took long time because 3 servers go down, and long time it took to replicate the copies or the data to the single one. But ultimately, it has the data. It has all the required partition. So still, it can work. I mean, that can be a possibility.
I mean, is it possible? I mean, is it a possible scenario that now in this scenario, right, Anand, you're mentioning the fourth server, right? It is having every partition copy, right?
Yeah, that's like why it's not possible. I mean, single broker, I mean, a single node, it can have partitions, all the partitions, right? I think it can have, right? I mean, it's
I
not.
doubt. So, I mean, you see, we have say a total here 3 partitions, right? Example, right? P1, P2, P3, correct? I don't think we will have all the 3 partitions in one server. I think it will try to replicate, right?
Yeah.
Thinking the scenario.
Because see, if you have only one, let's say we have only one broker in our
Sorry.
system, and you have kept the partitions as 5. So all the 5 partitions will be there in the single server. Now, if you have, let's say, increased to 2, now the first 5 partitions, how will they be organized?
Yeah.
Actually, that's the first question, that how they will be organized. Whether like whether the first will keep 3, the another will keep 2 or 4 1, or what will be the setting? And or I mean, this is not. How does it look? Not sure.
There is a formula to calculate this. So actually the formula is number of server failures is number of replicas we have -1 divided by replication factor. So that's how we will calculate. In this case, we have the how many number of brokers -1 by replication factor. We have 4 brokers. -1 by 3. So it will be 3 by 3. 1 failures we can accept. So that is the formula generally. N minus 1 by R. Number of brokers -1 by replication count.
Oh, that's the formula. Okay, can you put in the chat then?
Yeah.
I didn't know the formula. I was just, we were just trying, right, Anand?
Yeah.
Trying scenarios.
Yeah, N minus 1 by R. So where N is number of brokers.
Okay, number of brokers, and R is the replication factor.
R is replication factor.
3 minus 3 by 1. Okay.
So this is the maximum, like number of failures is this. This is the value. So in this case, 4 minus 1 by 3. 3 by 3, right? So it is 1.
Yeah. So Anand, in this given scenario, right, it is given, right, like 2 is the replication factor. So one server is down, we are safe. But the second server is down, then we might lose. That's what I was thinking around actually. But good to have a formula to clearly see the number of failures it can handle.
Yeah, it will be 1 point something if we got also like 1. That's how we can round. Suppose in terms of 5 brokers, right? 5 brokers, 2 replicas they will give. So
5 minus 1, 4.
4
by 2, it's 2.5. 2.5 means.
No.
So in this
Sometimes they'll give 6 minus 1 by 2 also, right? 5 by 2, 2.5. If you take 2, that's how we can measure. But this is the formula: number of brokers minus 1 by replication factor. I saw it. Let me share that link where I saw that in.
Okay.
number of server failures.
So in this case,
correctly. Sorry.
Yeah.
Go ahead, you.
Go on.
Yeah. So I was just thinking like this formula must be assuming that whatever the partitions, the replicated data will be distributed evenly across the nodes, right? So it is not like that on the single node all the replications are going on. So
It
that
will not be there. On the single node, all replicas will not save.
Yes.
right,
So while
That's the
creating the
replication
cluster
is
itself,
almost-
while creating the cluster itself, I think there are some properties we'll specify for creating the Kafka cluster. Then, so these based on these parameters only, we can set the replication factor while creating the topics. So if you have maximum replication factor than what we have, number of brokers, it will not allow. It will give error.
Okay. Because
I think
if we are
I think the replication factor, like we cannot have a replica on the same node, because otherwise there is no point of that replica, right? If the node is down, both the replicas are also gone.
should be evenly distributed across other partitions.
So now if we have 4 nodes here, right? I think then we can have 4 is the maximum replication factor. In that case, same partition copy will be having like 4 copies and one in each node in that case.
Interesting case. You were mentioning earlier that based on the key also, the data gets replicated into specific partitions. So when we
It's
have
not
such
replicated.
scenario,
It's not replicated. So data will be, for example, if you have a message, right? Message with ID 1. So it will go to, assume it will go to, you have 2 partitions, 1 mod 2. So what is the value? It will go to that partition. Second message ID 2, partition key is 2, 2 mod 2. So it will go to that partition. So it's not replica. So that message will go to one partition only. Replica means copy. How many copies?
And that copy will go to some different partition, right? Not the same partition.
It will go to the same partition only. P1 we mentioned into 2 brokers, right? Broker 1, node 1, P1, node 2, P1. So this P1 copy will be available in second node as well. That is the replica. In the architecture diagram where we have it first place. So we are mentioning P1 in 2 nodes. We are having the P1 copy in 2 nodes.
Yes, exactly. In 2 nodes, and those 2 nodes were partition 1 and partition 2, right?
Partition 1 only. P1,
okay,
P1.
Partition.
Same partition, Aditya, same partition, same exactly same copy. The idea of replica, like if that node having that partition is down, we are not losing the data, right? And it will always get it from the remaining one. So it is going to be the exact same copy.
Understood.
Yeah.
Understood, yeah.
A good discussion. We can move on if all good.
Consider the use case of real-time traffic.
Consider the use case of real-time traffic and routing service for the vehicles on the road. The traffic and navigation service is expected to handle requests from lot of cars. What will be the appropriate interaction pattern in the collection tier?
Oh, this is the generalized architecture thing.
Oh, it's not Kafka, it's generalized. Yeah.
Yeah, there is a collection tier, data flow tier, and then analysis tier. There is some tiers, right? I think analysis tier. After that, delivery tier. So I think they mentioned. Let me see.
So in collection tier,
Collection
what is
tier,
the
data flow tier, processing tier, storage tier, and delivery tier. So these are the 4 five types we'll have. So what will be the
Given
appropriate?
any pattern.
So there is a generalized streaming data architecture. Collection tier. Yeah, search for that, I think. There will be a diagram.
Yeah, that question also I think came in the quiz too, right? They were asking, highlighting us to highlight the section. Some
Okay.
people.
Let me put this image. It will be some image, I think.
Yeah, here
yeah.
next
If you
page,
go to the next slide.
Just next page, yes. Just go to the next page. Yeah,
Yeah, this one. So this is the generalized architecture. So now what they're asking is which tier? They're asking analysis tier and collection tier in question.
In collection
What
tier,
will be
what
the
will be the interaction pattern?
Interaction pattern in collection tier. Okay. Delivery semantics also they asked. Okay. What will be the okay, so there will be real-time traffic and routing service. The traffic and navigation service is expected to handle requests from a lot of. Okay. So I think, yeah, they are asking for the pattern. Okay, publish subscribe pattern only, right? So there will be three patterns actually. I noted somewhere. Request response pattern, publish subscribe pattern, and streaming pattern. These are the three patterns. So this for this given problem, request response pattern will not. Request response is the synchronous. Like if you send a request and wait for a response until that response came in. This will not suitable for this problem, right? It will be streaming of the data where different vehicles monitoring in the real time. So
yeah,
there will be
because there are
published
many cars. Yeah, there are many cars. It shouldn't wait to get the immediate response, like a synchronization. Yeah.
Is expected to handle traffic and navigation service is expected to handle. Okay, then there is another pattern is public subscribe pattern. That is another pattern. So I think they gave this. There is a streaming pattern, but streaming pattern in videos also I don't see they covered it. So this publish subscribe pattern is similar to Kafka. So if any vehicle want to enter to that navigation service thing, so it will publish to that and it will get those required information. Subscribe, publish, subscribe.
So the Kafka here, Kafka will collect all the input messages, right? Like a publish, and then our processing layer, it can like a consumes from it then.
But traffic and navigation service means this is I confused from the second one. The traffic and navigation service is expected to handle requests from lot of cars. So they want to control. So for example, if busy, right, one route is busy, so they want to stop and then send something, right? So for that, I think they are looking for publish subscribe pattern is a good example. Request response pattern will not suit here. Only we have these two patterns, right? Request response and publish subscribe.
So publish subscribe means we are just accepting the details requests from the cars, right there.
Yes.
But this is not us. This is not a synchronous, right? And since the
They
traffic is a real time, the traffic is real time. Oh, I think that is also possible, no? Like it's if we have a like a Kafka with multiple consumers to process the data, in real time, correct? So it gets the data from the cars, and then the consumers can pull the messages from the broker, and it can process and respond.
Yeah,
it is also possible. So I think publish subscriber pattern looks good.
Yeah, only we have those two. Request response pattern will not suitable because
why
it will wait
maybe
for
you can elaborate, because request response is also real time, right? You send some request and you wait for a response. It should be immediate, right?
It should be immediate for one.
So you're saying multiple requests will be fired.
Yeah, multiple cars will be there, right? Yes. So one car will go at a time. If request response means, since it is a synchronous, one car will move at a time.
Okay.
Remaining will be waiting there.
The queue.
Yes. How I am thinking is, if there is any red, like stopping, right? Red light is there, it will subscribe to that. So once all cars will be subscribed, once it is green signal, all will go. So that's what I'm looking this problem.
Okay, that's what I saying. Public subscribe pattern.
Yeah. But delivery semantics. So we have 3 delivery semantics. Exactly once, at least once, at most once. These 3 delivery semantics we have. So exactly once means it's a critical scenario. We need to get that message exactly once. So credit card, suppose any credit card transaction, only once we need to get the message. That is the exactly one scenario. But here there is no problem, right? There is no harm. If a car is waiting now and if it is going into the next signal also, it's not a problem, right? So I think at least once is the delivery semantics. But we have these 3 delivery semantics, at least once, at most once, exactly once.
Yeah, but see, it's a traffic and notice service, and if there are multiple responses, like if it is at least once, and there are multiple responses for a single request, so then how, like, the behavior will be the car, the movement of the cars. I mean, it can cause a lot of traffic, or the it can also lead to road accidents, right? Also, right? Like if it is like from that perspective, I see there is an impact here. Like if they don't get the accurate data, and or multiple responses they are getting against a single request, so it can lead to some chaos uh, on the road. I mean, from my perspective, it should be exactly once.
Okay. So there are 3 parameters, okay, which we need to consider. So for example, business impact, a degree of tolerance, right, and storage. So these, based on these 3, we'll come to that whether it is exactly once, at least once, or at most once. So I think we need to have those 3. What is the impact? Explain clearly and write our justification. I think what is the business impact? What is the degree of tolerance towards the message loss, and the storage aspect pertaining to the historical data. So these 3 we need to consider and derive that at least once, exactly once, and at most once. Yeah, as you told, I think we need to elaborate this and we need to write exactly once as per that description.
Yeah,
But
that's
this
right,
one,
and that's exactly right. Like tolerance and this storage, that is all that also needs to be considered while we decide the deliveries and the semantics. So I was aware of impact, but yes, this tolerance and the storage is also there. Yes,
yeah, I'm just checking
because it's the
what.
vehicles on the road. That's the reason if we like if our system is not robust, like it can lead to chaos. That's what I can think.
Yeah.
So you mean if we say at least once, then there might be a multiple entries, right, for the same incoming request data double.
Yes. In that case, your producer can produce one messages, but it can be delivered to the consumers multiple times. Okay. So
Yeah.
for some scenarios, for example, let's say operational monitoring. So where you can afford to have multiple duplicates in your logs. But in case of, let's say, this credit card transactions or vehicles on road, if we if we send multiple, if we have multiple responses for a single request, so then it can create some disturbance. So from that perspective, the impact will be more.
Yeah. I'm just thinking if suppose some vehicle has violated, right, some signal, and if we have to impose a fine, and if there is a duplicate, then the fine will be duplicate, right? Is that a valid
Yes,
scenario too?
yes, could be, yes.
Today only I got a relief from one of the fine, so it came in my mind. Okay.
So finally, which one you will write, at least once or exactly once or at most once?
Exactly once.
The logic is behind that.
See, there are three parameters. One is the business impact, right? And now we are designing a system for the vehicles on the road. Now, if your system is not robust, it gives you multiple responses. If it is at least once, okay, that means your messages can be delivered more than one. That means your responses can be delivered more than one for a single request. Now, if it is the case, so like as Yogesh just mentioned, that for let's say that some fine is generated, so duplicate fine can be generated, or some other some similar thing can happen. I mean, since here vehicles on the road, the impact can be more, right? So first thing will be the business impact. For example, if it is credit card transactions, so you cannot afford to have multiple messages, right? At least once this delivery, you cannot afford for the credit card transactions because the impact is more. Similarly, in this case also the impact will be more. So that is one thing. Now, degree of tolerance and storage part, I'm not sure like how we justify these two parameters while we deciding this exactly once.
But Anand, if you see the question, like they have mentioned here, right, the real-time traffic and routing service.
Mm-hmm.
So, I mean, if we keep aside that scenario of fine, right, but if we see only this real-time traffic and the routing service, then is it still be exactly once or more? Because say if I'm coming from a one way, right, some one side, but there can be, okay, no, that scenario too. Just trying to think of any scenario where it's at least once.
Yogesh. So actually, I was like in sync with what Yogesh was thinking. It's similar to what Google Maps does, right? It's
Yes.
basically, telling you where the other cars are, and you kind of understand that, right? So it's just about that, right? It's giving you the information back. So I'm not able to connect with the scenario of fines and all here. It's just about helping you for routing, right?
Yeah, navigation, right? Yes.
Navigation based on
So
the given question. Yeah.
if my route is showing to me as a red color or something, I will choose alternate route, or I will go by that route. So it's not like I need to go through only that route, right? So since so it will be at least once, I think, because it is up to us. Like it will not create any harm if we are talking about navigation. If you are talking about signaling, that is different part. If you are talking about navigation and these things, that is up to us whether we can choose that or not. It will not create any harm, any impact. So I can choose alternate route. It is up to my decision. So if you consider navigation, I think it will be at least once. If you consider the traffic signaling and all, then it will be exactly once. That's what I'm thinking.
Yeah. This can be, yes.
Yeah, because they given the traffic and navigation service is expected to handle requests from lot of cars. So it is, I think, as Vivek told, right? So it will be some Google Navigator, some kind of maps kind of a thing.
I think when we write an answer, right, it's probable to give an example also. So I think that would be
Yeah. In both cases,
supporting.
it is correct. Yes.
Yeah, supporting. We have to support the case also, right? Why we are saying.
There is reference of this case in the textbook which is given, but need to go through it and see.
Okay.
And even did you tried with ChatGPT? What it say something?
Can do that.
Just to confirm maybe, because you have the document open, if you can just copy and put it to ChatGPT.
But we cannot rely on it.
Yeah, we can just copy the question, I think, just now till cars, and then like a scenario and then question only. Just wanted to see what it's, what it says.
Actually, if we consider this degree of tolerance parameter, so what Shayak was saying makes sense, because if we have alternate routes, but I'm choosing only choosing to select only one. Like, so even though if I have given the wrong route or some other, uh, there's not. I mean, I'm not sure. Like, there won't be any real time impact. Let's see.
At least once.
Okay.
Yeah, it says at least once. And what's justification it is giving? Is it in line with what we are also thinking? Just to confirm, like we are on the right track.
Messages are sent.
Oh, okay. See, actually, I mean, if you see that one now, it is just making sure that these messages are delivered more than once also. So just to make sure these messages are delivered guaranteed, right? I mean, we are thinking in a different justification, no? But if you see this one with at least one semantic, the service can guarantee that it will receive the message from the vehicle, maybe 2 times or 3 times, right? But it will receive at least. But if it is exactly once, I think that will only attempt once, and if it fails, I think that message will be lost. So I mean, our justification, I mean, I'm not sure about this ChatGPT, but if we assume this is correct, then the at least once is the related to just to make sure the message is guaranteed. Why? Because it will send multiple times, right? At least once, so that it is received. It may be duplicate, but it will be received.
Now, see, in exactly once also you will receive the message. It's just that at that time you will receive only one time. There won't be any duplicacy. But in the at least once, there can be one or multiple message. They both guarantee message delivery, right? Only the at most once message delivery semantics, it does not provide the guarantee. There the message can be lost, right? Because at most one. But here in the case of at least once and exactly once, the message will be delivered. Definitely delivered. In case of at least once, it will be delivered. It can be delivered more than one time. That will be the only difference. But the message delivery will be there in both the cases, exactly once and at least once. Only the case at most once, where you can have no message or one message. There is the chance of message loss, but not in the other semantics.
Veena, can you please type in ChatGPT? Just say, will exactly once not work in this scenario? Just see what ChatGPT says.
Did we all get confused because just we tried ChatGPT?
Oh, okay. system guarantees that each measure will be delivered to the recipient.
Now the question is whether we are okay with duplicates or not, right? Based on that only we can select whether we go with exactly once.
Yes.
Yeah. Now in this case, can we afford to have a duplicate? Then we can say at least once. And if we are 100% sure, okay, we don't want duplicate, then it has to be exactly once.
The data volume will be high. So if we have too many duplicates, right? The storage will be
Well, I think I agree here with the point Shahid was saying, because this is mainly the routing information, right? So even if you have duplicate messages or duplicate routes or something, it is doable. I mean, the second parameter, degree of tolerance, I think that is like you can tolerate even if you have the duplicate message. A system can tolerate. It is actually not causing the accident, because it's mainly the routing information. I mean, what he was saying, I think looks correct to me as of right now.
Yeah, I mean, in this case, we are okay with duplicates too. So we can even go with. So
Then
can
at
we
least
say
once
then
is
both
good.
are right in this case? Both work, right? In this case, like we are receiving the data from the source.
Yeah, but then you probably also need to consider the storage, because see, exactly once also required. It is more complex as well. Okay, so uh, like at least once is easier to design. Like it is less complex.
Okay.
In our slides, there is some information why we are using this at most once and all. Can I share the screen for a minute?
Yeah.
So now it is changing its opinion about exactly. So
I think search for the delivery semantics in ChatGPT or something. So it will give what is the meaning.
So at most we can see
Del
screens, right?
yeah, PPT. Okay.
So here we have at most once means maximum once, right? Systems used for monitoring purpose, important to inform the admins about the problems. Not all data transmissions required. Down sample the data to improve performance. Data loss is approximately normal. Exactly once. Financial systems or advertising systems, every message has to be delivered only once. Data loss not affordable as it might be revenue loss. Achieved through queuing systems like QMQ or RabbitMQ. Usually queue semantics implemented on server side. Least ones. Balance two extremes by providing reliable message delivery by pushing the message handling semantics to the consumer. Consumers are free to implement message handling without bothered about the consumers. Data-built on application logic and handled in the application level only. Least ones. So exactly once. At most once. Maximum once. So this is some
Now,
monitoring.
at most means is zero or one. Zero or one. Either you lose the data or you get the data exactly once. It's either zero or one. Whether you don't receive the message or receive the message.
Yeah, there
That
is
is
a
at most one.
probability of data loss actually.
Yes.
Yeah. Exactly once there should be no data loss. So these two are the
Yes.
extremely opposite ones. Here there is a data loss, and here exactly once means one. There will be no data loss. But why is called exactly once? At least once means they might send it several times, right? Or what? Balance between by providing
Yes.
reliable message.
like there can be duplicate message also in at least once, but you will certainly get the messages in exactly once. You will certainly get the message, but only one at a time. At most once you will either receive the message or will not receive the message.
In this case, every message has to be delivered only once, exactly once.
Yeah, so what happens in case of exactly once delivery, only one processor takes the message. And in case of at least once, multiple processes can process the message they take from the queue and process it. So message can be delivered multiple times. The same message, everything same.
Data loss not affordable as it might be a revenue loss. Exactly once, at least once.
See, for a traffic scenario, what the consumer is looking at is whether you get a green line or a red line or an orange line, right? So for that, from an implementation perspective, as I think Yogesh or I don't know who was mentioning, it's more harder to implement an exact um, uh, exactly one scenario, right? It's okay to do a at least once, right? It's easier to implement, and it's just the three different green, red, or orange that you need to display, right? So for that purpose, it's okay from a traffic and navigation perspective. Maybe for a financial thing, we may have to go for exactly once because it's critical and you need to kind of do more processing on it, right?
Mm-hmm.
So for
Yeah, we,
traffic, this at most once is delivery is enough, right? Not all data transmissions are required. I think it's not a critical thing, right? Or what? At most once. This is for the financial, that critical application. We need exactly once delivery. At least once is reliable. Is a reliable message delivery by pushing the message handling. But see, at least once means it even if the situation is over, the time criticality is over, still it will try to give this delivery. That is not important actually in the case of traffic, because in the traffic we need live data, no? If the data is lost, then no use of the data sending it after some time, right? So at most once, maximum once is enough, I think. This is systems used for monitoring purpose. What do you think?
No, but if you don't get any information for routing, okay, so then uh, like then how will you manage? Like we need to have some information to take the decision real time, right? So if we don't have any message or we have message loss, so then it can be a problem, right?
So that's a critical application, right? Then if it is critical, then we have to use it. This financial systems, advertising systems, like every message has to be delivered only once. Data loss is not affordable, because here the data loss is not affordable. But for the traffic scenario, I've actually I missed the question. What is the question actually? Is it? I don't remember the question, exact question. So if it is just normal traffic mapping and all, then it's this data which is like 5 minutes old is no use actually, because we are we have crossed several kilometers. Then yeah,
Real-time traffic and routing services.
yeah, real time, right? So if the data is lost and if you are getting the data after 5 minutes, it's no use, right? So exactly once is not something which I can because after 5 minutes I am getting the data, lost data, so it's no use for me then, because I have already passed several kilometers. The previous 5 minute old data is not any use for me. But maximum once means okay, we can go for at least once. This is also the same issue. The real time for this monitoring purpose, I think I feel like this one. I'm not sure. Yeah, I'm just a guess. You can share it now. Yeah, if you want. Otherwise, we can go n plus one.
Uh, so for this real-time traffic routings, is data loss acceptable?
Yeah, because if you are losing the data and after some time when the connectivity is back, what's the use of the data which was happened 1 minute back, because you have already crossed the different so many kilometers, so the previous data doesn't is not valid, right, anymore. Yeah, just one. I mean, did I confuse you or what?
Let's connect back on this question tomorrow. Because
Yeah, can you show the question once more? I just missed that one.
yeah, no, before that, I will show you something. This exact scenario is here. So I need to read a little bit. So in chapter 2, right, they are mentioning this scenario, but they have taken this scenario in all the cases. So I need to read and finalize which one they have made it optimal. So this is the publish subscribe model. You're able to see the screen, right?
Yeah, yeah, yeah. Traffic.
So for all the scenarios, they have taken this traffic reason. I think for the above one also. So this is the request response one. And this is the publish subscribe. So need to read it and come back. Is the question.
Can you copy the question here, Veena?
Yeah.
Yeah, we'll give a try also later on, just to maybe next we will discuss also. But I think this makes more sense when we discuss, right? Rather than going through the lectures.
Consider the use case. Just show me the question once. This is a use case of real-time line routing around the road. The traffic analysis is expected to handle the customer node. What will be the appropriate interaction pattern in the published subscribe route? Such this message delivers semantics for exactly once. Test out the text storage requirements.
So I think here we will not like we should not miss the message, right? It's a real-time traffic, right?
Message, see, Yogesh, the point is if you missed it because of some network issue and you are regaining the network after 5 minutes, exactly once mean
Yeah,
after 5 minutes you will get the message. So what will be the
exactly. But
use of the message after getting like after 5 minutes, because you are traveling, you are going at
exactly.
100%
Yeah, yeah.
speed. So after five
Yes.
minutes, what's the use of getting this exactly one message, right?
Yeah. If it is delayed, there is no meaning, right,
No
for
meaning,
that.
yeah. It
I mean,
should be live
yes.
data, yeah. So it should be maximum once is okay, yeah. What's the use of getting redundant data again and again? Yeah. So whenever the network
But
is
if you don't in a route, if you don't get the data in the real time, like the route information, so then you will also lost, right? This can, like, you can also get lost if you're not getting the data in the real time,
you are right
right?
actually, but the point is like if you are having a network issue, you are having a device issue, and you are not getting the data real time, and after 5 minutes your system is back, but you are going to send all the 5 minutes data to the system, right? Central
No,
system.
but
Is the user
then
going to
this is
able to
not.
send the whole 5 minutes data? Because it's exactly once you need to send all the data, right? In the last 5 minutes, you will send it all the data. But what's the use of this in the central system? And what's the use
No,
for
I think here, Manoj, you are talking about reconnection, like the system connected again and it uh, gained the data. But what if the data is totally lost? Like you did not get the data for some data points, some period, and if you do, you did not get the.
actually, I'm
Hmm.
talking the same thing. Like you are traveling, and for some reason, the data is not getting there, and you are sending the data after 5 minutes. Okay, so what's the use of
Hmm.
this data, right? Because after 5 minutes, you are at a different point. You need to send that data only, right?
Correct. So Manoj, like what we are trying here now, if we have this at most once, right? So we are considering the case that devices are connected and all. So we are getting the message. But if we have this semantics set as at most once, and for some reason we lost, then we will not.
You are lost. Then that means you have
Yeah.
traveled a bit more, right? And you need to send the latest data, not the old data, right?
But if we have the other option, right, at least once, at least you would definitely get that message. It will not be lost.
Because after
If
5 minutes, you are regaining the connection, and
no,
you
no,
are
no, no,
sending.
not 5 minutes. No, 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 no. See, what we are trying to see here, two consumers, right? If somehow one is not able to get that message, but some other consumer can get a message, right? Say consumer is down, right? With at least once semantics, it is guaranteed that the message will be delivered and processed.
Again,
But if
same thing. Actually, I may be wrong, but the point is, what's the use of giving a live message after several much time? You need to send the live message
So,
exactly when it occurs, right? You are sending it, and it doesn't get delivered for some reason. But after 5 minutes, or 1 minute, or 5 minutes, or 10 minutes, you are
no,
sending
there
the.
will there will be no 5 minutes actually. It will be processed instantly by some other consumer because the message is not lost. Somewhere it is received and it is processed, right?
Again, I am saying same thing. Like you are traveling, and several kilometers you are going within few seconds. You are traveling, and this is gone, right? So in that case, what the live is more important than the old data. That's what I am trying to convey.
Correct, correct, correct. See, we are talking about the same message. We are
This
not
is
losing,
talking
right?
about one message that is generated every millisecond or every second. Okay.
But we are not
Your
having
current
seconds
message is
delay.
received there, but your old message is still pending. You are going to send the old message again. That's the problem.
No, 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 not old message. We are talking about only one message here only.
Yeah, one message is okay.
yeah.
That's the case actually. That's what I am trying to convey. Like the current message is different than the old message. What happened a few
See, if
seconds
you
back is a different message, and you are sending a live message, and that's the more priority, and the priority should be given to the present message. But if the old message has not received there, you are going to resend it after.
No, no, Manoj, we are not talking about here old and new message. The message is only once, right?
You don't send message
So
only once in a traveling car. I don't know. I may be mistaken. Okay, what I'm trying is you are traveling in a car. You are sending messages every millisecond or maybe every second. Okay, so some
Mhm.
seconds maybe the the data may be lost, but you are going to resend the old data again. Right? I think I am able to convey the information that you are
Mm,
no,
trying to
no,
convey.
actually, it will not be able to. Actually, it will not be able to regain the old data. See, if you read
exactly,
this
yeah.
question, there are multiple car requests. Some the real time traffic and navigation service is taking care of the request from the lot of car. Right now, for some time, like some messages or some request, some data got lost from some of the car. Now you are not able to keep track of the car because you lost the data. Now you will not be able to gain it again, right? Your data is lost. So this is the you say impact here. uh, like out of so many requests, some request data you lost, you cannot track it again, right? Or you can lose the track of it, or maybe if those cars, if they are following some routing like GPS routing or something, so they will get lost.
Okay, so what I was talking about is one car having sending a lot of messages every second, like every second it's sending messages, and you are talking about different cars sending the message, and some car are not able to deliver, right?
Yes, yes. If you read the question, it is like that only. That you this service is
Maybe I may be
receiving
wrong.
request.
I'm just trying to guess the question in this way. Yeah.
But actually, what you are saying is the reconnection of the network, right? But here, like you lost the message and then you lost the track. Now, is it impact? Can we afford this? That's a question. Can we afford this?
No, it depends on the, see, if network is having issue, if the device is having issue, then who can do? I mean, who can be held responsible for this loss, right?
No, that's different. But thing is, we cannot afford it if we have some routing service which is keeping track of car signal or whatever, and we lost it. For example, let's say that uh, like that. Okay, I don't know. Chandrayaan is the correct example for that. The second part, we lost in the last 2 kilometer difference. We lost the signal. Right now, what happened in those uh, 2 minutes? Scientists, ISRO scientists, they didn't know. So we lost it. I mean, it's not exactly the perfect, the best example, but it's like that. That can we afford to
Actually,
lose the?
that example, like Chandrayaan, you need all the information, so that so that is a different example actually, because you need to
Yeah.
study the travel and everything, so you need a whole information. But whereas in a live car system, what is
Hmm.
important is a live information, no? Something not something which was
Hmm.
happened few minutes back or few seconds back. Maybe I may be wrong understanding the question. Okay, so that's all from my side. Yeah.
Okay.
If we can just, this is what ChatGPT is giving.
ChatGPT only confuse all of us. But it's a good discussion. We were talking about now at most also, right? So
we can continue with
yeah, we can
data.
continue. I think you have already shared the question. Maybe we will do some homework in the next session. We can discuss. Maybe we can continue with the next question.
Okay, nice. Thank you, Veena. Yeah, it was a nice discussion.
So we are continuing, right?
Sure.
Spa.
Yeah.
What's the
Otherwise, we
plan?
can go back to that BDS, maybe Black Book or the Simacharya book. Yeah, right.
Yeah, we can do anything. Like I'm fine anything, either BDS or spa. I see spa is more interesting.
Today's discussion, we just share to the repository, no? Whatever the answer we have kept finally.
Yeah. Veena will share it.
Yeah. So what do you all think? Shall we continue spa or shall we switch to BDS? Let's check the majority. What do you think, Manoj?
We need to find out what are the topics to learn. Actually, I'm quite confused. In the SPA, we need only Kafka, right? Only Kafka is important. Huh?
Kafka, Zookeeper.
Those are different things or same? I thought it's.
Oh, you're in BDS. You are back in BDS, right?
No. I'm saying in SPA, what are the important topics? Kafka, I
Spa.
understood is
Okay.
important. Then what else? Because we have limited time and I don't want to learn everything.
Zookeeper, Kafka, Lambda, I think. And some tier architecture is there.
Then Kappa is something. No, that's not important, right?
But I think the best course, no, I think as we are going through the questions, we are able to see the kind of scenarios can come in the exam, no?
Yeah, actually, my attitude, I mean, the idea was to go through the questions and find the related topics and go through the
Topic.
concept also. Yeah, actually.
Okay.
So that was the idea, but we don't have time for that. Yeah. So
Yeah,
in
it's
the
too
SPA,
much.
we have only Kafka, Zookeeper, and Lambda as the most important ones, right? Let's keep it like that. Then what about BDS? We have the Hadoop and Spark, right?
So many things in BDS.
Okay.
Have map reduce also they're asking to write a
No, that is a
pseudocode,
part
right?
of Hadoop only, right?
Yeah. Again, it's a part of Hadoop.
Yeah, so I just mentioned Hadoop, then Spark. Anything else as a big one? Okay, let's keep it like that only.
Yeah. So will they ask any question about the pig or Hayu?
Yeah, that questions has come actually.
Just because everyone doesn't know, right? This is each is a separate, completely different set, right? I mean, pig is different.
This big hive is different from Hadoop. I thought maybe it's a part
No, 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 no. Hadoop is a framework, no. Okay, Hadoop is a framework, and we have multiple other tools, right? Like this Hayu, Impala, HBase, everything, right? Like, but like it is very difficult to get a good hands on with the code. I mean, in the code level, it's very difficult to get that kind of a grip, right, during this 3-4 months. So from that point of view, I was thinking, why they're asking code? Pseudocode I can understand, it is fine. But yeah, if they have asked, we can go through some examples to get a feel what kind of, how the pig script look like, or how the Hive query look like, no? That way.
Yeah, at least on the books, if you can identify the place where you can refer it in that time, that would be nice also.
Yeah, I have just Googled and found one example of Apache pig.